In this video, I'm going to be using the fundamental counting principle to find a probability. There are 11 balls numbered 1 through 11 placed in a bucket. What is the probability of reaching into the bucket and randomly drawing 3 balls numbered 4, 9, and 7 without replacement in that order? Express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. Alright, so the first thing we want to do is we want to find the denominator. And the denominator is going to be how many ways we can select 3 balls without replacement. So I want to use the fundamental counting principle, abbreviated FCP, and then I have ball 1 for my first event, ball 2 for my second, and ball 3. And for the fundamental counting principle, we multiply straight across. So if I'm selecting 3 balls and I have 11 to start with, there's 11 ways to select the first ball. And then we are selecting without replacement, so the next factor will be reduced by 1. So there's 10 balls left for selecting ball 2, and again without replacement we'll have 9 balls left for ball 3. Alright, so the denominator represents all ways we can randomly select 3 balls without replacement, and we're not looking for any particular ball or balls. Alright, for the numerator we are looking at the specific case where we get the ball 4 and then 9 and then 7. Now, nowhere in this problem do they say that those numbers are repeated. So I'm assuming that there's 1 4, there's 1 9, and there's 1 7. So again, using the fundamental counting principle, and this may seem a little silly because you may automatically see the numerator as being 1. There's only one way we can get that exact sequence of balls. But using the fundamental counting principle and creating little slots, there's only one way to get a 4, okay? One way to get a 9, and one way to get a 7. So there is only one way to get a 4 and then a 9 and then a 7. Okay, so don't be confused. This is not a set of fractions. Here you can think of these as slots, and then these would be the events. The event that I get a 4, event I get a 9, event I get a 7. Alright, so putting these two together, it's going to be using probability notation, getting a 4, then a 9, then a 7. It's going to be 1 out of 11 times 10 times 9. Also, this denominator can be thought of as 11 permute 3 because this is in fact a permutation. Alright, so getting that in my calculator, actually I didn't need a calculator for this, sorry. This denominator is 990 and the numerator is still 1. So this is a fraction in its most reduced form. You could leave it like that, or you could go ahead and convert that to decimal, and then rounding to 4 decimal places I have 0.0010. Okay, very small probability.